A simplest transformer consists of a primary winding and a secondary winding. This is the transformer core. The core provides a path for the magnetic flux to transverse. Current passing through the primary coil creates a magnetic field. The primary and secondary coils are wrapped around a core of a very high magnetic permeability, such as iron, so that most of the magnetic flux passes through both the primary and secondary coils. If a load is connected to the secondary winding, the load current and voltage will be in the directions indicated. A varying current in the first circuit produces a varying magnetic field, which in turn induces a varying electromotive force in the second circuit. When a load is presented in the second circuit, current flows, and thus energy is transferred from the first circuit to the second circuit. Hi, I'll be teaching you all how to derive this formula. So first, by induction law, we have this equation, Vp equals to Np, multiply the differentiating of the magnetic flux over time. So Vp represents the primary voltage and Np represents the number of windings in the primary coil. So same goes to the secondary equation, where Vs equals to Ns multiplied by the differentiating of the magnetic flux over time. So solving both equations, you have this equation 1 and equation 2 by shifting the number of windings over. So sub 1 into 2, you have this formula, and there you go, you have this Vp over Vs equals to Np over Ns, which is the turns ratio formula. So for either condition, power P equals to power S, which is the primary power equals to secondary power. So power equals to voltage multiplied by current. So Vp times Ip equals to Vs times Is. So solving at this formula, and by subbing this into this, you get this formula.
From the equation that we learned just now, we are given this example. Determine the voltage across R load, and hence find the power across R load. First, we find the voltage across R load. The equation given just now was Vp over Vs equals to Np over Ns. By subbing in what we already have here, Vp equals to 120 volts, Vs is unknown, equals to the number of turns in the primary coil, 10 over 1. By solving, Vs equals to 12 volts. Vs here is equals to R load here. Therefore, R load is also equals to 12 volts. Now we will find the power across R load. To find the power, we need Is. The equation given us now was Vp over Vs equals to Is over Ip. By subbing what we already have here, Vp equals 120 volts over Vs, what we found earlier, 12 volts, equals to Is, unknown, over Ip, 1 ampere. By solving, Is equals to 10 ampere. Now we find the power. Power across R load. Power across R load is equals to Vs times Is, which is 12 volts times 10 ampere equals to 120 watts.
If a light bulb is given too much voltage, then it will potentially burn out. We're going to put a current of approximately 125 volts through this transformer. Notice that on this side you have a large number of coils of wire, and on the other side you have much fewer coils of wire. This steps down the voltage. The stepping down is proportional to the number of turns on the wire. For example, if there are 100 turns of wire on this side and only 10 turns of wire on this side, then the voltage on this side will only be 1/10 the voltage on this side. Remember, the voltage on this side is 125. After the step-down transformer, the voltage is a mere 3 volts, which is all you need to light these light bulbs without blowing them out.